Wirin. I'm from SMA Mondial, Class 3 IPAA, and today we'll be learning physics with me. Particularly, we'll be learning about the Bernoullis law. I said law, did I? So it is actually the Bernoullis Principle. I was getting a little bit too diplomatical right there. Sorry for my mistake. Okay, carry on. Law. I can enhance so many R's in my words. Carry on. The Bernoullis law. So we're in this pandemic. Have you ever seen somebody spraying alcohol to their hands, or when somebody is using a face mist, or when you're making projects, you're using spray paint? So have you ever looked at a spray and wonder, like, how does it work? What's in it? Like, why do you apply force down but the fluid comes out? There's actually physics in it. So the principle that is working in it is called the Bernoullis Principle. It's one of my favorite chapters. I don't know why, because it's very simple, it's easy to learn. So today I'll be explaining to you about the Bernoullis Principle. So what's the Bernoullis Principle? So it essentially states that the velocity of a fluid is inversely proportional to the pressure of the fluid. So the higher the velocity is, the faster a fluid is, the lower the pressure it has. One thing we should know as well is that the velocity of the fluid is also inversely proportional to the area of the pathway that is going through. So you can actually see this, examine this in real life when you're watering your plants with your hose. If you squeeze the hose, the water will squirt out faster. But if you release it, you don't apply force on the hose, the water will actually goes out slower. So that's one thing. So velocity is also inversely proportional to the area. So when you squeeze the hose, making the area smaller, or the volume smaller, area of the opening smaller, so the water will comes out quickly. So how do we apply this to sprays? So I'm gonna explain how this principle works on sprays. When we push this is called the trigger. This is the trigger part. When we push this, it actually, there's a spring inside, so the cylinder is smaller inside. This will push the cylinder up, so making the volume here smaller. The volume smaller, the area is also smaller. So the area is smaller, so the velocity here is higher, increasing the velocity. The higher the velocity is, the pressure will decrease, the lower the pressure. So the velocity here, the velocity of the fluid here is actually a constant because nothing is acted towards it. So the velocity here is a constant, making the pressure here is a constant. So the pressure here is still the same, while the pressure here is decreasing. Higher pressure, lower pressure. Fluid travels from high pressure to low pressure. So it actually forces the fluid out from the cylinder and out through the nozzle. So this same principle actually also works on perfume. Like when you push this, you apply force to it, you push this, it actually it increases the speed of the fluid inside this, in here, on the upper part. Well, it also decreases the pressure here. While the pressure is decreasing, the gradient of the pressure becomes larger, so there's a gradient of pressure. The pressure here is still the same, it's higher than the pressure here because the velocity here is still the same, while the velocity here is increasing. So higher pressure, lower pressure. So the fluid inside travel from higher pressure to lower pressure out through the opening. So remember that velocity is inversely proportional to the volume or the area of the pathway that it is going through, and it is also inversely proportional to the pressure of a fluid. Thank you. today. If you like this video, give it a thumbs up. If not, leave it. Share. And thank you for the attention. See you next time if my teacher give me the same project, which I hope not. But that's it. Cut.